You've probably heard of it, right? R. It pops up all the time in articles about data science, AI, but what is it really? Well, today we're going to pull back the curtain and demystify the R programming language, which is no joke, one of the most powerful tools out there for making sense of our crazy, data-filled world. I mean, think about it. We are swimming in data. It's everywhere, from scientific research to what's trending on social media to how a business is doing. But honestly, all that information, it's just noise until we can find the patterns, the connections, the stories hiding inside. So how do we actually do that? How do we turn all those raw numbers into something that means something? For a whole lot of researchers and analysts, the answer is R. It was created way back in the 90s by two guys, Ross Ihaka and Robert Gentleman, and they built it for a very specific job, crunching stats and making graphs. And here's the best part. It's free. It's open source, which means anyone, you, me, anybody, can download it right now and start digging into data. Now, if that word language makes you nervous, like you're thinking of super complex, scary programming, just take a deep breath. R is what we call an interpreted language. That just means you type a command, you hit enter, and poof, it runs. Instantly. There's no complicated waiting around for a program to compile. It's more like having a back-and-forth conversation with your data. To really, truly understand R, you just have to get your head around one single core idea, and it's this. In R, everything is an object. Seriously, this is the master key that unlocks the whole thing. And this quote, this gets right to the heart of what makes R so different. See, unlike a lot of programs that just spit out an answer on the screen, R takes the result of whatever you did, and I mean anything from a simple calculation to a massive statistical model, and it stores it in a named object. You don't just see the answer, you get the answer as a real thing you can pick up and use again. So, what is this object thing? The easiest way to think about it is like a labeled box or a container in your computer's memory, and you can stick almost anything you want in that box. A column of numbers, a whole spreadsheet of data, the results of a fancy test. You can even put a whole graph inside an object. You give it a name, and from then on, you can just call it by its name. And just like in your kitchen, you've got different kinds of containers for different jobs. A vector is for one simple thing, like a single column of data. A matrix is your basic grid. The one you'll use all the time is a data frame. It's pretty much a spreadsheet with rows and columns. And then you've got a list, which is like the ultimate junk drawer, a super container that can hold a mix of absolutely anything else. All right, so theory is great, but let's see how all this stuff actually fits together. We're going to take a quick little conceptual road trip through a typical data analysis just to see how these objects play out in the real world. Most of the time, it boils down to these 4 key stages. First, you've got to get your data into R. Step 2, you'll almost always need to clean it up or reorganize it a bit. 3, you do the real work, the actual statistical analysis. And finally, my favorite part, you visualize the results, so you can actually see and share what you found. So step 1 might look something like this. You use a command, a function, like read.table, to grab some data from a file. But look at that little arrow. That is the single most important symbol in R. It's the assignment operator. It's you saying, hey R, go read that file and then take everything you find and stuff it into a new object that I'm calling my data. And once your data lives inside these objects, you can play with them so easily. You can just add 2 objects, X and Y, together, just like on a calculator. Except here, you're not just adding 2 numbers. You could be adding 2 entire columns of data, and you assign that new result to another object called Z. This simple idea scales up to some really heavy-duty analysis too. This single line of code here, it's running a full-blown analysis of variance, or ANOVA, which is a pretty complex statistical test. And the entire model, every last number and result, gets neatly packaged up and stored in one single object we called AOV.spray. And finally, bringing it all to life. The plot command is the perfect example of R's elegance. You just tell it, hey, plot these 2 objects, and boom, it generates a graphic for you. And as we're about to see, this is where R really starts to show off. Okay, so that was the how. Now it's time for the wow.
Because the real payoff, the real magic of working in R isn't just about getting the right answer. It's about creating visualizations that can show you things, reveal insights that you might never have noticed otherwise. Right out of the box, a basic plot in R is designed to be simple and clear. It's clean, it's professional, it does its job perfectly well. But that's just the starting line. It's where the fun begins. This word, flexibility, is everything, because R's true power gets unlocked through something called packages. The best way to think of a package is like an app for your phone. It's a special toolkit that extends R's abilities in amazing ways, and anyone can build them and share them. So, for instance, a package called Lattice lets you create what are called conditional plots. So let's say you're looking at earthquake data. Instead of one messy plot, you could tell R to show you the data in separate panels for shallow, medium, and deep earthquakes. Instantly, at a glance, you can see how the patterns change with depth. You're telling a much, much deeper story. Or how about this? What if you've got tons of variables and you want to see how they all relate to each other? With R, you can make a scatter plot matrix that visualizes every single relationship all at once. For a famous data set about iris flowers, you could instantly see how petal length relates to petal width, how sepal length relates to petal length, and on and on. It's like speed dating for your data. And R can create some seriously advanced visuals that let you spot patterns that would otherwise be completely invisible. Check this out. It's called a parallel coordinate plot. Instead of an X and Y axis, each variable gets its own vertical line. Then each data point, in this case each flower, becomes a line that weaves its way through the variables. You can actually see how the different species create their own unique visual fingerprint. It's an incredible way to see the hidden structure and complex data. So, R is clearly a phenomenal tool for analyzing and visualizing data. But there's one final layer to it. The thing that really turns it from just a program into a true language. And that is, you can build your own tool. You do this by writing your own functions. A function is nothing more than a custom tool that you build yourself. Let's say there's a task you have to do all the time, like reading a certain kind of file, cleaning it up, and making a specific plot. You can bundle all of those commands into your very own reusable function that you can call with just one word. And this is a total game changer. Just as the manual says, it allows for an efficient, flexible, and rational way of working. You're not just using the tools that somebody else gave you anymore. You are creating your own tools, perfectly designed for what you need to do. You're actually speaking the language. So, when you put it all together, you see that R isn't just a program you run. It's a language for asking bigger, better, and more interesting questions of your data. It gives you the power to shape information, run incredibly sophisticated analyses, create beautiful, insightful graphics, and even build your own tools from scratch. It turns data from a boring list of facts into a playground for discovery. So, the only question left is, what stories could you tell with data?